Well, here's another day, another video in geometry. This video is called Circles 14, and it's going to be about special segments in a circle. This is actually section 10.7 in your textbook. When we talk about special segments, it turns out inside circles certain things happen that are really nice. And so if we look at the diagram, we have a circle here, and we have two chords, AB and DC, and AB intersects DC at point X. And what happens is that we can say that AX times XB is equal to CX times XD. And that's going to be true in every situation where you have two chords that intersect like this. So we're going to do a problem, but I'm going to show you why this is true, which is something I haven't done before. So really quickly, if I draw this line here and I draw this line here, what I want to know is why are these things going to be true? And what I notice is this angle is equal to this angle by vertical angles. And this angle is equal to this angle because if you look, they're both inscribed in the same arc. So therefore, these two triangles are similar by our old friend, the angle-angle theorem. And if they're similar, then ratios of corresponding sides are equal. And so you could say that CX over BX equals AX over DX. And when you cross multiply, you actually end up with our little formula that we're going to use. So a couple of ways to remember this one if you forget that you can multiply the two pieces on the chord times each other is you could just remember that these triangles are similar and you could take corresponding pieces and set up equal ratios. And once you have the ratios, then that's essentially the same thing. And that's why this theorem works. So let's look at an example. So here's a very simple application. What we see is we have two chords intersecting in a circle, and therefore, according to the theorem, the two pieces on each chord, if you multiply them together, they're equal to the product of the two pieces on the other chord. So we can say automatically that 5 times 12 equals 6 times x. And that leaves us 60 equals 6x. And then we divide by 6. And so 10 is equal to x. And we are done at this point because we wanted to find x. And so here's our second example. As you notice, we have two chords right here. The chords intersect, and so what we can say is that the product of these two pieces is equal to the product of these two pieces. And therefore, we can write x times x plus 10 is equal to x plus 2 times x plus 7. Alright, now you have to remember a little more algebra to do this one, but if you look at it, we do a distributive property. So we get x squared plus 10x. And on this side, we will multiply by FOIL and collect like terms, and you should get x squared plus 2x plus 7x plus 14. Alright, now we have to collect like terms. So what I'm going to do is subtract x squared from both sides because I want to get them on the same side. So I end up with 10x equals 2x plus 7x is 9x plus 14. And then I subtract the 9x because I need to get the x's by themselves. And that gives me x equals 14. And so now I solve for x. And if you want to check, just to make sure, you can substitute. So we'll have x is 14 times x plus 10, which is 24. Is that going to equal, that's our question, is that going to equal 14 plus 7, 21, times 16? And when we multiply that out, 14 times 24 on a calculator is 240 and 96, so it's 336. And 21 times 16 is 210 plus 126, which is still 336, so it checks. So this is how you can check your answer, is by plugging back in and then checking with the theorem. So for practice, why don't you try this one and find x. So I'm back. If you were finding x, you would have said, oh, 10 times 10 is equal to x times x. So you would have got 100 equals x squared, and then you could have taken the square root of both sides and said x equals 10. So this is a case where everything was equal to the same thing. Kind of a simple problem, a little redundant, but nice and tricky, just to see if you knew the concept. Okay, good luck on your assignment today in class, and we shall talk tomorrow with the last video for 10.7.